The Beer-Lambert law, also known as Beer's law, is a fundamental principle in the field of spectroscopy and analytical chemistry. It describes the relationship between the concentration of a solute in a solution and the amount it absorbs. This law is essential for determining the concentration of a substance in a solution and is widely used in various scientific and industrial applications. Here's a concise explanation of the Beer-Lambert law in less than 5 minutes. Basic principle: the law states that the absorbance, A, of a substance in a solution is directly proportional to both the concentration, C, of the substance and the path length, L, of the sample through which the light passes. Mathematically, it is expressed as A is equal to epsilon times C times L, where A is the absorbance of the sample. Epsilon is the molar absorptivity or molar extinction coefficient, which is a constant unique to each substance and is dependent on the wavelength of light. C is the concentration of the substance in the solution, usually in moles per liter, m. L is the path length of the sample that the light travels through, usually in centimeters, cm. Linear relationship: the Beer-Lambert law assumes that the relationship between absorbance and concentration is linear, meaning that as the concentration of a substance increases, its absorbance also increases proportionally. Wavelength dependency: the molar absorptivity, epsilon, is specific to the substance being analyzed and the wavelength of light used. Different substances absorb light at different wavelengths, so it's essential to choose the appropriate wavelength for analysis. Applications: quantitative analysis: the Beer-Lambert law is widely used in chemistry to quantitatively determine the concentration of a solute in a solution. Researchers use spectrophotometers to measure the absorbance of a sample and then calculate the concentration using the law. Quality control: industries such as pharmaceuticals, food and beverage, and environmental monitoring use the Beer-Lambert law to ensure product quality. For example, it can be used to check the concentration of a specific ingredient in a product. Environmental monitoring: scientists use this law to measure pollutant concentrations in natural waters and air samples. Biochemistry and molecular biology: in these fields, spectrophotometry is used extensively for assays like enzyme kinetics and DNA quantification. Limit: Beer-Lambert law assumes that the solution is dilute, meaning that the absorbing species does not significantly interact with other molecules in the solution. In concentrated solutions, deviations from linearity can occur. It assumes that the path length is constant throughout the sample, which may not be the case in certain real-world situations. It works best for monochromatic light sources, where only one wavelength is used.